9 times a to the fourth plus 12 times a squared times b squared plus 4b to the fourth. Which of the following is equivalent to the expression shown above? In the previous questions, we haven't paid much attention to the answer choices given to us, but in this case, it might be useful to scan them. So two of the answer choices offer us a situation of squaring of two binomials, and the other two, B and D, they offer us putting a binomial into the fourth power. As you might guess, it's probably not as difficult as it seems, and that it is unlikely that we're asked to raise anything to the fourth power. But let's take a look. One tip in preparation for the SAT is that many of the intimidating problems are not meant to be difficult. That whenever you see something as intimidating as possibly this case, is probably calling on you to recognize some sort of a pattern. So for now, let's assume that we're not dealing with anything that we need to raise to the fourth power, but rather see if we can see a case of squaring of a binomial. Let us bring back all three special cases that we discussed in the previous video. The squaring of a plus b, also squaring of a minus b, and multiplying sum with a difference. If any of these cases applies, it is the first one, since it has a form of a square plus 2ab plus b square. And what we're given actually uses only pluses. And second and third case, they do have a minus featured in both cases. In the first case, it's minus b squared. In the second case, it's minus 2ab. So if we were to assume, we are probably best served to focus on the first case for now. Let's see if the pattern that we recognize applies to the problem that we're given to solve. So the problem we're given is 9a to the fourth plus 12a squared b squared plus 4b to the fourth. And we suspect that it is a variation of x squared plus 2xy plus y squared, which is, as we know, and we learned in the previous lesson, is a square of the sum x plus y. As we proceed, let's assume that x squared is represented by 9a to the fourth, and y squared is represented by 4b to the fourth. So let's try to see if the remaining part, which is plus 2xy, is represented by 12a squared b squared. To do so, let's unwrap the square. If we are assuming that 9a to the fourth is an x squared, from that it means that square root of 9a to the fourth should represent x, which is a square root of x squared. And if that were the case, then our x equals 3a squared. In the second case of 4b squared as y squared, we can use the same technique and find what represents y in this squared format, which would mean that we need to take a square root of 4b to the fourth to represent y. And it's rather simple calculation. Square root of 4 is 2. Square root of b to the fourth is b squared. So our answer is 2b squared. This way, we have derived that 2xy is represented by 2 times 3a squared times 2b squared. And if we perform this operation, we get 12, which is a multiplication of 2 times 3 times 2, a squared, b squared. And this is exactly the middle part of the expression we're given. With this information, we can finish solving our problem. We can see that x is represented by 3a squared, and y is represented by 2b squared. And so this whole expression is a square of these two inputs into the binomial. So 9a to the fourth plus 12a squared b squared plus 4b to the fourth is the same as the square of the sum of 3a squared plus 2b squared. It seems like a very complicated problem, and just following the analysis here might get you confused. I recommend that you take another shot at it and independently try to understand it at your own comfortable pace. And once you do so, you would recognize that it is not nearly as confusing or difficult as it seems. And it is very natural to doubt yourself whether you'd be able to solve this kind of problem, assuming this is slightly outside of your comfort zone. But if you trust the process and continue applying and studying these tools, you will do just fine recognizing these patterns and solving problems such as this. The correct answer is answer choice A.